Okay, so question 6 on this exam paper, it's solve the simultaneous equations. So again, these are two linear simultaneous equations, so we can solve this via elimination. So if we solve this via elimination, we write down the first equation, we write down the second, and then what we'll do is we'll make the second equation, the x value, the same, so we'll times this whole equation by 5, which would give us 5x minus 15y equals 45. And now what we can do is we can subtract the two equations, so we'll label them first, 1 and 2. Now if we subtract, we get subtracting, and we'll subtract 1 from 2. So what we get is minus 15y minus y equals 45 minus 21. And again, this is because the x's cancel. So minus 16y is equal to 24. So that means that y was minus 24 over 16. And again, 4 goes into them. 6, 4, and then 2 goes 2 times, and then 3. So y is equal to minus 1.5. Then we just need to find what x is. Well, x is equal to 9 plus 3y by rearranging the above equation and then putting in the value. You get 9 minus 9 over 2, which is 18 over 2 minus 9 over 2, which is just 9 over 2, which is 4.5. So we've got x is 9 over 2 slash 4.5, and y is minus 3 over 2 slash minus 1.5. Okay, next question. The diagram shows a square ABCD with sides of length 20. We have a semicircle and an arc of a circle. So again, the semi is here, and the arc overarching it is all the way over here. AB is the diameter of the semicircle, AC is the arc of the circle. Show that area of shaded region is area of the square, and when we divide them we get pi over 8. So in order to do this, we can firstly decompose the different areas and see how we can create them. So area of shaded region divided by area of square. Now we can write that as well. The area of the shaded region would be the same as the area of this arc here. Subtract away the area of this semicircle. So we can write that. So area of arc minus area of semicircle. And therefore we can figure out what this is. So the area of the arc, well, if we add in here on our diagram, this would be 10, this would be 10, And again, these are all 20. So the area of the arc would be a quarter of the area of that circle. So we'll write 20 squared times pi times a quarter minus 1/2 of the area of the circle with radius 10. 10 squared, like this, all over the area of the square, which is 20 times 20. So if we do this, we get a quarter pi. 20 times 20 is 2 times 2, which is 4, times 100, which is 400, minus 1/2 pi times by 100 over, and then that will be over 400. So if we do this, we get 100 pi minus 50 pi, which just give us 50 pi on the top over 400, and again cancel, and then 5 goes into 5 once, and it goes into 48 times. So we get pi over 8. Next question, write down the exact value of tan 45. I think this is a standard value that you should know, so we know that tan 45 is 1. Here's a right angle. We're given cosine of 60 is 1/2, work out x. So we can label our diagram. So this would be opposite, hypotenuse, adjacent. We have the adjacent, and we want to find the hypotenuse, so we know we use cosine. Cosine of an angle, adjacent over hypotenuse. So it's the cosine of 60 equals the adjacent, which is 4, divided by our hypotenuse, which is x. So we get 4 over cos 60, and we're told cos 60 is 1/2, which gives us 8. The time of 48 trains left a station on Monday were recorded. Okay, the cumulative frequency graph is given here with the delays. The shortest delay was 0 minutes, the longest was 42. On the grid, draw a box plot for the information about delays. Well, the main things about the box plot is that we need to plot the quartiles and then the range. So to find the quartiles, we know that we have 48 trains. So lower quartile would be a quarter of 48, which would be 12. Median would be halfway, would be a half of 48, which is 24. And the upper quartile would be 3/4 of 48, which would be 36. So now what we have to do is, now that we know that, let's just plot those lines and see if we can read off. So 24 would be somewhere here. 12 would be here. And 36 would be here. So what we can do is we can rub some of this into the paper. So we get 12, 24, 36. And the values we get are 4, 10, and 20. So now adding everything in, we've got a line at 0, a line at 42, and again let's just do a convention where we draw it up to here. Then the median is at 10. Let's do that a little lower. And then we've got one at 4. And then we've got another value at 20. So now connecting it all up, again, it's important to use a ruler. We have something like this. So the next question says compare the distribution of the delays on Monday with those on Tuesday. When comparing, just pick, say, the median and the interquartile range as a comparison. So we say on Monday, the median delay was greater and then we quote some numbers, 10 compared with 9. And then we can also say the interquartile range, which again here is 4. So 4 minus 20 is 16. And the range here is 6 and 6 minus 17, or 17 minus 6, which gives us 9. So we can say on Tuesday, the interquartile range was smaller. And we can say 9 compared, or should I say 11 compared with 16. Okay. Next one, Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 minutes and 30 minutes. Is Mary correct? Well, the longest delay on 33 minutes, which is correct, so that first statement is true. But then she then goes on to say there must be delays of between 25 and 30 minutes. Now, in order to answer this question, we assume that she's representing the part in the box plot, which is in this area here, so 20 to 30 minutes in this region. Now, there's a chance that this might not be the case, and the reason is that what we can say is that with the upper quartile being over here, we can say that the upper 25% of the trains, so that would be another 25%, which would be 12. So upper 25%, which is 12 of the trains, may be between anywhere within this range. So by looking at the box plot, we have no way to determine that all of them are between the range that's specified. So is Mary right? No, since we cannot determine this. Determine this just from the box plot. We know upper 25% of trains had a delay between 17 to 25 or 30 to 33. So we don't exactly know whereabouts it could lie within that range. Next question, simplify this. So if we write this out fully, we have 2x minus 1s, so we can cancel an x minus 1 on both the top and the bottom, so we get 1 over 5 x minus 1. And then we can expand this if necessary, so it's 5x minus 5. Next, we're asked to factorize fully this, so we can pull out 2, and then we've got a 25 minus y squared. And now if we notice this thing inside the brackets can be written as a difference of two squares, where we have something squared minus something else, and that is factorized in this format. So here in our case, this can be written as 5 squared minus y squared. And so we have 5 minus y, 5 plus y, like that. So that's our answer. Again, it doesn't really matter which way round you write it. Perfect.